Okay. This is the review for the Quad 2 test. The first 4 questions is asking to multiply the polynomials. So when we multiply our polynomials, we use that process called FOIL. So FOIL is first times first, and then your outers. So 2x times 3x is a 6x squared. 2x times a 2 is a positive 4x. And then we have an I and an L. The I stands for the inners, and the L's stand for the last of each term. So negative 1 times 3x is a negative 3x. Negative 1 times 2 is a negative 2. From there, we combine like terms. 4x minus 3x is a 1x. You do not have to write the 1. So we have 6x squared plus x minus 2 would be your answer for this one. Okay, moving on to this one right here. You do have to know that 5x minus 4 quantity squared is the same thing as 5x minus 4 times 5x minus 4. First and outer. Inner last. And you, of course, can use a calculator to get those numbers. Combine like terms. And this would be the simplified version. All right, moving on to number 3. We're just going to go a little quicker each time. So first, outer. Inner last. In this one, negative 3x plus 3x is 0. So they combine to be 0, which leaves us with 9x squared minus 1. Now we should have known that the middle terms were going to 0 out because this is a difference of squares. So 2 binomials with the same a value and the same b value with a positive and a negative are going to come out to a perfect square right here. All right, number 4 looks very similar to number 1. First and outer minus, that's a 30x. And then inner and last. Combine like terms. Negative 30 plus 20 is a negative 10x. We still have the 40x squared out in front and a negative 15 at the end. And I always like to show you how to check your answers. So when you are simplifying, what you start with, let's do this one. What you start with and what you end with should be the same. So the easiest way to see this is to use Desmos and get a picture of both of these parabolas. When you do this, they should look exactly the same because they're the same equation, just one is written in a different way. This is the expanded version. Okay, so if I type in 10x plus 5 and 4x minus 3, and then our answer you should get a parabola right on top of itself because it should be the same exact parabola. And as you can see, it is. So we can say check, we did that one right. All right, moving on to this one, it's asking us to factor out the greatest common factor. So what we're going to do is we're going to see what do these two have in common. Well, I can divide both of them by 3. And this one has 1x and this one has 2. So they both have 1x in common. When you have variables, it's always going to be the one with the smallest exponent. So what we're going to do next is actually do the division, okay? We're going to take out that factor of 3x. 3 divided by 3 is 1. X squared divided by x to the first, you subtract these two. So that's going to be x to the first minus 9 divided by 3 is 3. And then x to the first divided by x to the first, anything divided by itself is 1. Now, I'm writing those ones on purpose. Of course, we do not have to write them. So like the one in front doesn't need to be written. The one as an exponent doesn't need to be written. And then times 1 doesn't need to be written. So this right here would be your final answer. All right, let's look at this one. Let's see, what can I divide both of these terms by? All right, we got 6 and 5. Both of those, they don't have anything in common. I know that because 6 is 1 times 6 and 2 times 3. And then 5 is only 1 times 5. The only number they really have in common is 1. Dividing by a 1 doesn't change anything. Okay, let's look at our A's. We have 2 A's in this one. We have 1 A in this one. So that means we can take 1 A out of both. We have 1 B in this one and 2 in this one. So we can only take 1 B out of both. Here we have 2 C's and 1 C. So we can only take 1 C out of both. And let's see what we're left with after we take out a factor of ABC. That 6 is not being divided by anything. A squared over a to the first. Subtract your exponents. That's going to be a to the first. B to the first divided by b to the first. Anything divided by itself is 1. C squared divided by c to the first. 2 minus 1, we get c to the first. Okay, now we know that we do not need a power of 1. We don't need to write it. We don't need to show that it's being multiplied by 1. There we go. And we also don't need to write the c as an exponent of 1. So really, it's just going to be 6AC. Let's clean it up a little bit. Okay, it's going to work now. Or it should. Good enough. Okay, so 6AC. Plus the 5 stays a 5. It has nothing to be divided by. A to the first over a to the first is 1. B squared over b to the first is b to the first power. And then c to the first divided by itself gives you 1. So this would be your final answer. Now because we have more than one variable, unfortunately we cannot check this one, but we could check this one because it is both just one variable. So we can type this in and the original and see if they are the same parabola. Let's see what we get. All right, so we've got 3x squared minus 9x and 3x parentheses x minus 3. See if they are the same parabola. They sure are, so I at least know that one is a good answer. All right, moving to number 7 and 8, asking what is missing. It says that these are equivalent, right? There's an equal sign. All right, let's see here. Well, when I have a number outside of a parentheses, that's showing that if I was to distribute it, it would give me this one. So right now, 2 times 2x squared is 4x squared. So that works. Let's do this one in the middle. 2 times what is going to give you the middle term? So 2, oh, the minus is already here, so we don't have to worry about that. So 2 times a missing number gives us 6. 2 times 3 gives us 6. And then 2 times, we're still missing something. We're trying to get to a 6x. So 2 times 3x. 2 times 3x gives me 6x. All right, and then moving on to the third term. So 14, this plus is already here, is supposed to be 2 times this one. So 2 times this missing piece gives us 14. That would have to be 7. All right. Now this one is working backwards. That's okay. 5t times 1 is supposed to give us this first one. Yep. So the next one we're going to have to do is 5t times a negative, which you'll notice is already here. So 5t times a 4t. 5 times 4 is 20. T times t is t squared. Okay. Both of these can be checked in Desmos because they only have one variable. Let's check this one. So what you would do is type one of them in and then type the other and see if they are the same parabola. (5t minus 20t squared). Let's see, why is it giving me the triangle? It says try adding y equals to the beginning of this equation. Okay. Oh, interesting. It actually worked. I did not know that. What I always do is I make this into an x instead of a t, and it works. All right, let's do the next one. 5x parentheses 1 minus 4x. See if these work. Are they the same? Sure are. Check. Okay. Moving on to number 9. Factor by splitting the middle term. Okay, factor by splitting the middle term, or, sorry, I'm trying to figure out why this is crooked. It's driving me nuts. Okay, factor by splitting the middle term or using perfect square trinomials or difference of two squares, the patterns. So let's start with this one. I did the box method with my classes, so let's start with the box method. So in the box method, the first term goes at the top left, the last term goes here, and then the way I like to organize my factors, so we're going to multiply. Remember, it's a times c, so 1 times a negative 22, and then your b term goes down here. List your factors of 22. Always start with one and then move to the other. Okay, how would I get a negative 9 out of those? Well, I know that the difference of these two, just right now, the difference of the two is going to give me a 9. But I want it to be a negative 9, so the bigger number needs to be negative. I'm going to put this 2x here, negative 11x here. from here, what we do is find the GCF. I like to do this one first. So you're asked, what is in common out of these two terms? It's going to be an x. Ask yourself, x times the top of this box is supposed to give you x squared. X times the top of this box is supposed to give you 2x. Moving on to this one. X times this piece of the box is supposed to give you negative 11x. Double check and make sure it works. This box is supposed to be the top times the side, so 2 times negative 11 is negative 22. So factored form would be these two written like this in whatever order. All right, let's do number 10 by using splitting the middle term. I know a lot of teachers do it this way as well. So if you were to split the middle term, it is very similar. We're going to do that, try to find the factors again. So we're going to find the factors of 4. Maybe it looks like this. So 4 is 1 times 4 and 2 times 2. And they need to add, subtract, combine to be a negative 5. Well, I know that 1 and 4 together make a positive 5. So that means that negative 1 minus 4 gives us a negative 5. So this is going to be a negative 1x, a negative 4x. Drop down the x squared and the 4. And then we are going to factor by grouping. All right, what's in common in both of these? An x. Let's see what we get when we take that out. Subtract your exponents. X divided by x is 1. All right, what's in common in both of these? If the first number is negative, you need to pull out a negative. Let's see what's left. Negative 4 divided by 4 is 1, so x. And 4 divided by negative 4 is a negative 1. I forgot to put a plus here. Okay, these should be the same. So you get to factor out an x minus 1 from this whole thing. So if you look at this right here, if I was to factor out the x minus 1, I'm left with an x. And if I was to factor out an x minus 1, I would be left with a minus 4. So this factors to x minus 1, x minus 4. All right, number 11, I'll stick with box method for the left-hand side. 3x squared at the top left, negative 20 down here. Multiply your a times your c, that's a negative 60. Negative 7 down here. Ooh, don't forget to divide if you can. So if you can take out a common factor, make sure you do that to make your numbers smaller. All right, 60, 1 and 60, definitely not going to give me 7. 2 and 30, nope. 3 and 20, nope. 4 and if you don't know, you can always use Desmos. Let's do that. 4, what are we doing? 60? 60 divided by 4, 15. Still not there yet. What about 5? Ooh, that'll give me 7. All right. How am I going to get a negative 7 out of those? A negative 12, right? 5 minus 12 is negative 7. So 5x, negative 12x. Let's see what's in common. 3 and 5 don't have anything in common, so just an x. X times the top gives us 3x squared. X times this top is supposed to give me 5x. Looking at this, 3x times this gives me a negative 12x. Double check and see if it works. This is supposed to be a negative 4 times a positive 5, which is a negative 20. All right, so our final answer is the left and the top of my box. So that's an x minus 4 and a 3x plus 5. And you could have put the 3x plus 5 first and then the x minus 4. It does not matter. All right, let's look at this one. We'll do this one by splitting the middle term. But first, 6 and 16 and 8 can all be divided by 2. All right, let's see what we're left with once we take out that factor of 2. 6 divided by 2 is 3. 16 divided by 2 is x. 8 divided by 2 is 4. Okay, this is going to be the one that we are splitting. So multiply your first times your third. That's going to be 12. So factors of 12 are 1 and 12, 2 and 6, and 3 and 4. And I need to get a negative 8. So similar to last time, I know that 2 and 6 together give me 8, positive 8. So that means if they're both negative, they're going to give me negative 8. So splitting this into a negative 2x and a negative 6x, drop down that plus 4 and drop down that 3x squared. Don't forget you still have that 2 out in front. All right, we are now going to factor by grouping. Let's see, what's in common between these two? Just an x. So if we were to pull out an x, we would be left with 3x squared divided by x to the first minus x divided by itself is 1, so minus 2. And then again, if this first number is negative, your GCF has to be negative. They both can be divided by 2. And let's see what we get. So this becomes a positive 3x. 4 divided by negative 2 is a negative 2. Don't forget, we're just going to keep going. Okay, so if I was to factor out that common factor from this one, factor out the 3x minus 2, I would be left with an x. And this one, if I was to factor out a 3x minus 2, I would be left with a minus 2. But we can't forget that we factored out a 2 in the beginning. So this needs to stay the same. All of these are the same parabola. They're just written in different forms. So factored out, this becomes 2 times 3x minus 2 times x minus 2. Okay. And you can check your answer because these are just equivalent forms of one another. Let's check number 12 since that was the most complicated one. Using Desmos, let's type in the original. So 6x squared minus 16x plus 8. Where'd it go? Minus 16x plus 8. And then my answer, 2 parentheses. Let's see, I don't think we need, let's see if we need that extra set. Green was my original, purple is the answer. They are the same, so we did it correctly. And it looks like we actually did not need that extra set of parentheses. I didn't know which one to erase. Okay. So 2 times 3x minus 2 times x minus 2. There we go. All right, moving on to 13 and 14. These are two terms, okay? And if you can notice that you can take the square root of them and get a good number. I wanted to do two different colors. Do this one. There we go. Then that means you can use the formula that says a squared minus b squared is equal to a plus b times a minus b. So here, the square root of x squared is x. The square root of 49 is 7. So this is in this form. X squared minus 7 squared. 7 squared is 49. So that means we can write this in this form. Plus and minus. The square root of x squared is x. Again, so like this right here, the square root of a squared is a. And then the square root of b squared is b. So 7 and 7. Same thing here. Let's see, the square root of 36 is 6. The square root of x squared is x. The square root of 25 is 5. Because they're perfect squares, you can take the square root of them. 6x will go here and here. 5 will go here and here. And again, we are just simplifying. We are writing these differently, but they are still the same thing. So that means I should be able to type in my original and my answer and see if it gives me the same parabola. Okay, so we started out with 36x squared minus 25, and I factored it to be 6x plus 5 times 6x minus 5. All right, so the black was our original, the red is our answer, right on top, so that means we did it correctly. All right, moving on to 16 through 19, which is saying find the specified solutions for each table and graph below. Okay, the specified solutions. So each one is specifying a different solution. This one is asking to find when f of x is equal to 0. Look, f of x is right here, right? F of x is equal to 0 here and here. The solution is your x values. So when f of x is 0, x is negative 2 and 3 with braces. All right, this one is asking to find when f of x is negative 4. In a table, your f of x is going to be the right side. It's like a y. And we have a negative 4 here and a negative 4 here. So to find the solution is your x value. So find when y is negative 4, your x value is negative 1 and 2 with braces. All right, moving on to a graph. F of x is equal to 0. Let's say you're taking the test and you're like, what? I don't remember how to graph that. You can always just type it in. Let's see if it works. F of x is equal to 0. So that looks like it is a straight line going left and right on the x-axis. So that's right here. Your solution is where they intersect. And again, it's just those x values. So that's negative 3 and 1. And then moving on to number 19. F of x is equal to 6. Again, if you ever forget, open up Desmos, change it to 6. A horizontal line at 6. And where do these intersect? This is going to continue here and here. And what are my x values? -1 and 3. All right, the table shows the values of a quadratic function. Based on the table, what are the solutions for the following? All right, remember what a quadratic function means. A quadratic function has symmetrical points. So if it has one point, it has the exact same one directly across from it. So if you remember, they have symmetry, and it looks like we're going to have to actually find the difference of these. Interesting. Or, oh, nope, they were nice. They're asking, what is the solution for each of these? So what is the solution for when f of x is equal to 0? F of x is equal to 0 when x is 0 and what else? That's interesting. All right, well, it's going up and it's going down. I wonder what this looks like. Let's move on to this one and see. So what about when f of x is equal to 0.90? Well, that's this one, when f of x is equal to 0.90. One of them is -4. But it should have another one, right? Because it has symmetric points. Now, normally they would give you one of the symmetrical points, but it has not happened. And because they're such ugly numbers, you know what I'm going to do? I'm going to be lazy. I'm going to let it do the work for me. And let's see, if I was given a table, I should be able to get the equation from Desmos. It looks like that's going to be my vertex. Let's see. Quadratic. It is. Okay. So if this is my vertex, then when x is, let's see, zero. Oh, this is my vertex. That's why. Okay, I got it now. 0, -3 is my vertex. What color shall I use? This is my vertex, which means it's going to look like that. Okay, so this is going to be -0.225. This one is going to be 0. This one is going to be 0.375. And this one is going to be 0.90. 1, 2, 3, 4. Okay, So when f of x is equal to 0, there we go, there's two of them as we knew, right, because they're symmetrical. All right, so when x is negative 2 and 2. 0.90. When x is negative 4 and 4. Okay. Moving on to numbers 21 and 22, solve the problems by factoring. Well, this one is already factored for us. Sweet. So what we get to do is set each one equal to 0. And again, we can do that because the zero product property. So if I know I'm multiplying something times something else and it gives me 0, then one of these is going to have to be 0. So we have to find out both options. Okay, subtract 1 from both sides. X is going to equal a negative 1/2. Add 7 to both sides. X is going to equal 7. Solve. So you're going to say x equals least to greatest. So for this one, we're going to have to factor, or it'll end up looking like this. All right, I'm going to do the box method. X squared, negative 18. Factors of negative 18 that combine to be a negative 7. I can stop there because I know the difference of these two is 7. So when I get a negative 7, that means my bigger number is negative. Common factor is just an x. X times x is x squared. X times 2 is 2x. X times a negative 9 gives us a negative 9x. Double check. 2 times a negative 9 is a negative 18. Okay, so this becomes x minus 9 and x plus 2. Set each of these equal to 0. I should have done this elsewhere. So this spot right here, whatever is supposed to be here, I am moving down here. All right, so we've got x minus 9 is equal to 0. X plus 2 is equal to 0. So both of my values, least to greatest. All right. Now I know that this is not, what am I trying to say? These aren't equivalent pieces, but you can still check your answer. So what you can do is you can type this into line 1 and line 2. So this purple one, line 1. This green one, line 2. Line 1. This is only to check. Line 2. Here's line 1. And I'll make it purple so it matches my color codes. And then line 2 is supposed to be 0. Now it's not going to graph anything unless I put a y equals in front of it. Make this green. All right, so our solution is where these two intersect, and we get negative 2 and 9. Is that what we got? Negative 2 and 9. So we did get the right answer. Comparing our equation that we started with to our answers. Moving right on along. Number 23, we're still solving. Okay, so 2 terms. Can we take the square root of both of them? Square root of 9 is 3, square root of x squared is x. Square root of 25 is 5. So we can. Equal to 0, plus, minus. Set them equal to 0. Subtract 5 from both sides. Divide by 3. Add 5 to both sides. Divide by 3. Write your answers from least to greatest. All right, this one has 3 terms, but it's not equal to 0. So the first thing we need to do, move this over. When I move that over, it changes its sign. It's the same thing as subtracting 5 from both sides. And now we're going to factor this. First, check if 6, 13, and 5 can be divided by something, and it can't. So we're going to factor it. And I did box method last time, so let's do split the middle term. Okay, multiply, that's supposed to be a 5, not a 15. There we go. Multiply a times c, that's a negative 30. 1 times 30, 2 times 15, that gives me 13 already. So the difference of these two is 13. To get a negative 13, that 15, the bigger number is negative. So 2x minus 15x. Drop down the negative 5 and drop down to 6x squared. This 2x was positive. Okay. Factor by grouping. What can I take out of both of these terms? They're both divisible by 2, and they both have an x. So if I was to take a 2x out, 6 divided by 2 is 3, and 2x divided by itself, Okay, sorry. 6 divided by 2 is 3. X squared divided by x to the first is x. Plus 2x divided by itself is going to be 1. If the first number is negative, your GCF is negative. You can divide both of these by 5. So if I was to pull out a negative 5, negative 15 divided by negative 5 is 3. X, and then negative divided by negative, negative 5 divided by negative 5, anything divided by itself is 1. Okay, now you can see that 3x plus 1 is a common factor. So if you're looking at this term only, and I take out 3x plus 1, I'm left with a 2x. If I look at this one, I take out a 3x plus 1, I'm left with a minus 5. So that's what's going to go here. And now I can set both of these equal to 0. All right, we get two answers, least to greatest. And let's check our answers. Oh man. Okay, so right here, you check your answer against the one where you made it equal to 0. So I want to use the same colors. Line 1. Line 2. Remember, you're going to have to type in y equals 0 to get a picture of that. So I'm just checking number 24 in Desmos just to show you how to do that. All right, line 1, 6x squared minus 13x minus 5, y equals 0. Negative 0.33. Let's see, we got negative 1/3. That is the same decimal that we got. And then 2.5. We got 5/2, which is 2.5. So where they intersect is the solutions, and we got them right. All right, number 25, use a table and graph on the calculator to solve the following inequalities. Write the solution using interval notation. Okay, so what we're going to do is just draw a tiny little sketch, okay? So draw yourself an XY axis. We want to get a picture of this. Let's see. Negative x squared minus 2x plus 8. So it crosses at 0, 8, here and here. Really, we just need these. So negative 4 and 2. And then it goes up and it comes back down. All right, and it wants it to be, see, when is it less than 0? Let's see. Less than the line y equals 0. So we need to draw this line as well so that we can see what we are comparing the parabola to. And it's asking, when is this, what color? Can't be pink. What about purple? Okay. When is, it's got a less than sign. Less than means below. And I did make a mistake. These, less than also means an open circle. There we go. Okay, so an open circle, and less than means below. Below. So that's my arms, right? The arms part of the parabola. And remember, this arrow means that it continues, and it continues. This is the part of the parabola that's below, but our solution is going to be in terms of x, which means we need to know the x values that are the solution. So this piece of the parabola are these x values, and it continues. And this part of the parabola are these x values, and it continues. It may help if you recreate this just on an x-axis. 0, we got -4 here, we got 2 here. They are open circles. And it shades this direction. And we still need to write it in interval notation. So the left arrow is representing that it's going left forever, so that's your negative x values. All of those is negative infinity. It stops at -4 with a parentheses because it's an open circle. There's a break in our solution. Starts again at 2, again, open circle, not included, parentheses, and then it continues going. Remember, an arrow pointing to the right is positive infinity, an arrow pointing to the left is negative infinity. Open circle is parentheses. If there is a break, there's a union symbol. This is my solution. All right, let's move on to letter B. Let's get a picture. The only important points here are the x-intercepts at 1 and 5. Less than is an open circle. And this one is pointing up at 1 and at 5. Okay. And I guess I'll just, in black is the parabola. And then this one here is what we're going to be comparing it to. So y equals 0. So we did the parabola in black. We're going to do the horizontal line in green. Again, it's the x-axis. Here we go. Oops. Right here. Less than. Less than means below. All right, so when is this parabola below? Hopefully you can see that is this part of the parabola. I called that the belly of the parabola. And again, we write our solution in terms of x. So those x values are just those right there. So it might be easier if you just look at the x-axis. We know that 0 is here, 1 is here, 5 is here. Open circle, and my solution are these. So remember parentheses, 1 to 5. Done. Parentheses because it's an open circle.